Let's look at graphing a rational function with holes. For example, let's graph this function here. Let's first factor to see if f is in simplest form. So we have f of x is equal to. Now we can factor a 2x out of the numerator, which gives us 2x times x plus 3. And the denominator factors into x plus 1 times x plus 3. Now let's notice a few things about this function. Its domain is the set of x values such that x is not equal to -1 or -3, because then we'd be dividing by 0. But moreover, f does have common factors, which means it's not in simplest form. But we can put it in simplest form by canceling these x plus 3's as long as x does not equal -3. That is, f of x is equal to 2x divided by x plus 1 as long as x does not equal -3. Okay, now that the function is in its simplest form, we can graph it. So let's first start by looking for its asymptotes. Now, a rational function in its simplest form will have vertical asymptotes at the zeros of its denominator. So looking here, x plus 1 will equal 0 when x is equal to -1, which means this function has a vertical asymptote of x equal to -1. And what about any horizontal asymptotes? Notice here that the degree of the numerator is equal to 1, which is also the degree of the denominator. And therefore, this graph will have a horizontal asymptote at y equal to the ratio of the leading coefficients, which is 2 divided by 1, or y is equal to 2. Now let's find a few points on this graph on either side of this vertical asymptote here. Let's make a table. We have x and y. So when x is equal to 0, for example, we can plug 0 in down here, and we get that y is equal to 2 times 0, which is 0, divided by 0 plus 1, which is 1, and 0 divided by 1 is 0. So y is also 0. And when x is equal to 1, we can plug 1 in down here. We get that y is equal to 2 times 1, which is 2, divided by 1 plus 1, which is also 2, and 2 over 2 is 1. So y would also be 1. And when x is -2, again, plugging in down here, we get 2 times -2, which is -4, divided by -2 plus 1, which is -1. So the ratio would be 4. And then when x is equal to -4, for example, and notice we're skipping -3 because -3 is not in the domain of this function. So when x is -4, we get 2 times -4, which is -8, divided by -4 plus 1, which is -3. So y would be then 8/3. And so using all this information, we get our graph. Here's our vertical asymptote here. X equal to -1. Notice that as x goes to -1 from the left-hand side, f will increase without bound. And as x goes to -1 from the right-hand side, f will decrease without bound. And here is our horizontal asymptote. Y is equal to 2. And notice as x increases and decreases without bound, f starts to behave like this line. And here are our points. 0, 0 is here. It's on the graph. 1, 1 is here. -2, 4 is here. -4, 8/3 is here. And notice there is a hole in the graph at x equal to -3. Because x equal to -3 is not in the domain of this function. And evaluating f of x equal to 2x over x plus 1 at x equal to -3 gives us 2 times -3, all divided by -3 plus 1, which is -6 divided by -2, or 3, which means this hole is located at -3, 3. But that point is not on the graph of this function. All right, and this is how we graph rational functions with holes. Thank you, and we'll see you next time.